Let's take a look at the Hey Mahi number 4. And in this case, we've got a quadratic equation again. This time we're also noticing that this one has got two distinct roots. We're also noticing it's the b value that we're not sure of, which means there's going to be a range of values and we're going to have to calculate that range when we get to the end. But let's rewrite this out so it's a proper quadratic. It's going to equal 0 because, in other words, it's ready to be solved. So here it is. It's x squared plus m plus 2x plus 3m equals 2. I'm going to subtract 2 from both sides. So this is all going to equal 0. It's going to be x squared plus m plus 2x. Oh, sorry, x. I might make it a bit tidier. M plus 2x. So by that, I mean this is the coefficient of x here. The coefficient of x here, of course, is a 1. Not written in there, but we know it's 1. Plus, and this is now going to be 3m minus 2. So this is the coefficient of the fictitious, that you can't see, the x to the 0, x to the 2, x to the 1, x to the 0. And we now have a quadratic equation. But in our quadratic equation, we can't really solve it because we've got unknowns, we've got unknown coefficients. And of course, the thing that we use to resolve unknown coefficients is the discriminant function. So let's look at the discriminant function. And of course, the only thing we know, of course, is because we have to find the b value as part of this, and because it has two distinct roots, or in the case of no distinct roots, the same would be true, we have to use the discriminant function. There'll be a range of values at the end, so we have to do an extra step or so. All right, so let's see how this all plays out. Nice and straightforward, this one, by the way. So let's see. So we've got an a value of 1. We've got a b value of x plus 2, and we've got a c value of 3m minus 2. So we're going to plonk all this straight into the discriminant. Here it is. The discriminant is for ac. In this case, we know it's got two distinct roots. It has to be greater than 0, therefore. Yeah. So let's have a look at that. We're looking at bits that are greater than 0. So how does this play out? Well, we've got b. Well, it's going to be an x. Oh, I put x. Why did I put x plus 2? It's really m plus 2. Here we go. Let's make sure we've got an m written in here. This is going to be an m plus 2. My bad. Sorry about that. Okay, little mistakes like that can really derail you later on in an exam, so don't do that. Yeah, I kind of catch them because I'm looking at them and I'm thinking, no, wait a second, that's not how I can see this. Because you can see where it's going to go, and you know how it should end up looking at it, and after a while you just get good at working out, well, what should it look like? And if the numbers don't match where you think it should go, you go back and think, now this, if you've got 2 times 2 equals 4,000, then you're thinking, no, I've made a mistake somewhere. All right, so anyway, it's b squared. That's going to be m plus 2 squared minus 4 times a is 1 times c is 3m minus 2. And I want to try and get these inequality signs all kind of over each other, okay, or everything under each other, right? So here we go. So I'm going to rewrite this m plus 2. I'm going to expand those brackets out. 4 ones are 4, 3m minus 2, and I'm going to make that under each other. Good. So m times m is m squared plus 2m and 2m is 4m, and 2 times 2 is plus 4 minus 4 3s are 12m. Negative 4 times negative 2 is plus 8, greater than 0. I'm keeping them under each other now. Now we can do some wizardry here. We can just simply collect like terms. So I've got a 4m and a negative 12m is going to be negative 8m. So I've got m squared minus 8m. I've got a 4 and an 8 is plus 12 is going to be greater than 0. So I can actually find out, I can solve this now actually, because this is a little quadratic in itself. So I've got 2 brackets here, greater than 0. Got m, and the signs are going to be the same, both negative. Factors of 12 that add to 8, well, it's going to be 2 and 6. So you can say either m and I'm just going to use equals here, is equal to 2, or m is equal to 6. So I can actually draw that now as a diagram. Here we go. So, and I'm going to make this here m, and this value y. And I've got a 2, and I've got a 6. There it is. So it's going to look something like, it's going to come down, it's going to turn around, and it's going to head up like that. That's my parabola. There's my 2. There's my 6. There's my 0. Now, but we know that this is only true when this is greater than 0. Well, less than 0 here, these are all less than 0 values. Greater than 0 values are these ones here. These are all greater than 0, all greater than 0. So greater than 0 lies on the plane where the values of x are less than 2 or greater than 6, not less than 6 and greater than 2, which should be this bit in here. We don't not interested in that, but we're interested where it's going to be positive, 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 positive. These values here are all 2 or less. So what we're going to say is the value. So in fact, I'm going to rewrite this out. I've got the range of values of the constant m, so that the equation blah has 2 distinct roots r, and then we can write that down. This time I'm not going to write it, I'm going to let you write it, yeah? So the range of it, so I'm going to say the equation blah has 2 distinct roots. This is what you write. The equation blah has 2 distinct roots, and you can put, so this is a therefore statement, and you start off with the equation blah has, and I'll let you write that out, 2 distinct roots, and then at the end you say when, and we want to say m in this case is going to be less than 2, or m is greater than 6. And that is the solution.